Okay, so now we have Janis Keuper from Fraunhofer. Janis?
So, okay, thank you very much. Okay, good to be back after over 2.5 years. I'm running a group that's called Large Scale Machine Learning at Fraunhofer ITWM. In Germany, we're a public research institute. And maybe if you've been here in the last years, recall that I've been given several talks over the last years, especially in the area of how to scale up data-driven and machine learning applications on HPC systems. So I'm personally coming from the ML and deep learning field, and trying to scale this on large systems does not only require the algorithms, but also managing the software stacks and everything. So today I'm going to talk a little bit about cloud. Who of you has heard of Gaia-X? No one. That's actually really good. Gaia-X is actually a gigantic public research project or joint industry research project. It's kind of a $100 million size, publicly funded European project. Most like the American exascale program. Here the European Commission, driven by Germany and France, is trying to set up, well, what they say is the European alternative to hyperscalers. Before I get into the details, one thing I've learned in this conference, you need to have a disclaimer. In this case, it's the Gaia-X project is a very large project, and I'm not an official representative of this project. More like I'm a technical lead in a project that's sitting on top of this, kind of an early adopter. So I'm expressing my own opinions here, but I'm kind of a early adopting user, getting some experience on what this might look like. Okay, let's dive into it. And the introduction is, you haven't heard about it, but if you were watching the news in Europe, you probably would be aware of this. It actually made some news because there's so much public money spending in this direction of European Union, driven by France and Germany. You actually have some high-rank governmental officials here announcing the European area of the privacy-preserving European vision of what a cloud should be. So this is all high politics, so it's kind of top-down initiated. What I want to take you to is more like the technical side, maybe the idea of it. Okay, but one word for the motivation. Why would Europe spend hundreds of millions of dollars on kind of reinventing the cloud? Well, because if you look at the statistics, and if you actually deal with industries, I do a lot of projects with German car manufacturers, for example, and over the last years, they've massively moving from their own HPC systems to hyperscalers. And if you look at the statistics, well, you will have to dig down very deep in these others here to find any European company there. So this really hurts. That's why the politicians are actually willing to spend that much money. And of course, there's this other aspect is that at least from a social perspective in Europe, we have a lot of different ideas how you should deal with personal data. It's totally different. So we kind of always have this conflict that in many cases, companies are actually not allowed to process data on US-based hyperscalers. So you can't do it. If you're large enough, these hyperscalers come to Germany and build your data center, and you're fine. But if you're kind of a mid-sized company, you face these troubles. So this is kind of the political motivation of this. And what does Europe do if they've kind of faced this kind of problem? What have they done in the past? Well, in the US, you probably call it a moonshot project. In Europe, we always like to refer to the one project that actually worked out, which is the Airbus, right? It is kind of this same kind of project, top-down. Countries get together and build a new thing, and now we are actually in a position where I think, at least for the last year and this year, Airbus is exceeding Boeing actually by a margin. So that when politicians think of the European cloud, they think of it like this. And of course, they think like, privacy, transparency, and all of these kind of politically engaged values we want to embed. But of course, maybe you recall the last time Europe tried to change the internet. What did it get you? These little pop-up boxes where every website you go and you have to click yes, I agree to get a cookie and process my data. So, well, we'll see how this will work out. Let's move to the technical side of it. Beyond all the politics, there is a fundamental problem with how to manage larger data-driven projects in clouds today. And I sketched this up with this little boxes. So think of a data-driven workflow. You could think of autonomous driving. We do a lot of things in there. Or you could, as we're here in Houston, think of a data-driven process, maybe in seismic modeling. You have different data sources, and then you have this pipeline of different pre-processing steps, and then you have different modeling steps, and in the end, you might end up with a software tool. Now, of course, if you run all of this on your private HPC system with one single company involved, you do everything on your own. There are a lot of challenges in there, but you're kind of used to it. So what happened now is in the last year, everybody moved to the cloud, and we've also seen a large division of labor. So nobody's doing everything in this pipeline on their own. They're specialized companies, right? They're data providers. Companies, they go out, they actually record the data. They have the ships. The next company is doing some pre-processing. Other company has specialized migration algorithms. Maybe you have two different companies. They do two different migrations. You have the next companies trying to combine this. Then you have kind of pre-stack and post-stack processing and so on. Then you have the physical modeling. Now we have the AI guys coming in. And they might not take the same input data as your physical models used to. And you want to combine this. In the end, if you are kind of at the end of this chain, if you are one of the big oil companies in this city and you want to have your entire process going, you probably end up talking to, 5 to 20 different companies. And some of them might be even subcontractors and sub-subcontractors. You don't even get to see. You don't even know who's processing it. So how do you set all of this up in a kind of cloud environment, and how do you do that? So the question is, to make this work in this division of labor with specialized companies and specialized partners, of course there are a lot of technical issues. So how do you actually transfer these data? Each of these sketched arrows here actually there's data going from one point to the other. How do you manage this? Maybe this process is not run at the same time, but maybe some of the data has been acquired 5 years ago and the next one later. Some pre-processing has been done. So how do you manage not copying all these large volumes of data or even move them around from one data center to the other? How do you define APIs and data formats? So if a new company is coming in, that their algorithm will work on your data. How do you manage this? How do you control access to the data? If you own the data and you want to sell it, or you want to sell usage of that data, how do you control this? How do you actually orchestrate this to run this? How do you need to know if someone's providing an algorithm, what are their hardware requirements? How do you manage this? How do you maintain portability if you are such a service provider? You don't want to only run on AWS, you also want to run on Google and all the other systems. So how do you do that, and how do we keep it secure after all? On the administrative side is, of course, how do you, manage all this? How do you protect your IP? How do you ensure your compliance requirements? And so on. In the end, the bottom line is, how does this work today? Well, essentially, and I guess everyone who's moved to the cloud knows this, you go to the biggest player, the biggest fish in the pond, and they set the rules, right? If you're top chain big oil company, you make a nice contract with your favorite hyperscaler, you probably get pretty good conditions for moving your petabytes of data there, and then you force everyone else in this chain to move to the same system you are. And this might sound nice for you if you're top food chain, but still, for everybody else in the game, it's a problem. Especially if you're some service provider and you have different customers on different platforms, you need to make this run all the time. Every customer has different APIs and so on. And in the end, you end up with many, many data transfers, which is essentially bad. You end up with something I call one-time APIs, which kind of for every setup you have, you custom engineer an API for your algorithm, for your data, and so on. And after all, you kind of need an army of lawyers to set all of this up. You have contracts and so on. And this is a huge problem in practice. And this is kind of where this idea of a European cloud actually kicks in. Because what this European cloud actually is, it's not a cloud. There's no hardware, there's no data center, there's nothing. The idea of this Gaia-X European cloud actually is only to define standards how to make this division of labor possible and how to make it, find standards for answering all of these questions. Of course, this is still a moonshot, right? And the current state of the system, I will show you in a second, can only address some parts of it currently. But that's kind of what the goal is, to define an ecosystem, how to have a shared labor cloud ecosystem, which still could run on a US-based hyperscaler in the end. That's why they're actually involved, which is a big political problem in Europe. But in the end, people realize that we don't have the companies to do it. So basically, the idea is to enforce the standard upon maybe the world, if this is not too big of a. So what does it do? This is actually kind of a official diagram that's always being used to explain it. It looks a little bit difficult. That's why I want to dissect it for you in 3 or 4 slides. So at the core of it is something that's called the Federation services. So one of the key ideas of Gaia-X is not to reinvent the wheel, right? There's huge amount of open source software out there that will basically do most of the things that are set as a goal. We just need to make them to interact with each other and to set some standards. So there's no new identity management system. We'll just use OpenID. There's no new scheduler. We will adopt open source available schedulers. There's not going to be all of these essential parts. So basically what you have at the core is an open source project which kind of gives you a toolbox to build such an ecosystem. It's also not a unified ecosystem, as you will see in a second. It's basically kind of only a toolbox. So if you want to look at the current state and the capabilities of this, I don't want to go into too many details. You can actually look it up on GitLab. You can see what the current state is, and you can see the specifications of what the system is supposed to be doing end of this year. The planned final stage probably is going to be middle of 23 to be more realistic. So then one central concept is the concept of data spaces, which also means is that the idea of Gaia-X is not to build one monolithic set of rules for a cloud, but more use this toolbox here and build your own data space. And the data space is kind of the economic system, how people interact as you need. So there's no central entity. And basically, there's several projects already funded. But the idea is, and that's kind of the part where it's getting interesting also for you, even if you're not in Europe, is because you can use this to build your own ecosystem, let's say for seismic processing. Building such a data space defines what the APIs look like, what the data center, what the data formats are, and how these contracts of how a service could interact with data and how rights are automatically transferred. And in the end, if you set up such a data space, and the core idea is that setting up such data space, of course, needs everyone participating in this data space to agree on something. But then you only have the lawyers there once. Once you set it up, you can dynamically generate new projects in this data space without having these digitally signed contracts, without having the lawyers over this again, without having the technicians again in there and discussing how the APIs should look like and so on. So that's kind of the key idea. And these data spaces can be public, so you can just take a bunch of companies and start a new data space and invite everyone, or you can make them private and say, well, that's just ours, and we don't want to have anyone inside. We don't approve, and if you can have any mixed form of that you like. So the part we are actually working on is more on the infrastructure part, mostly on how to actually schedule things. The key idea here is actually to use self-description of services and self-description of hardware and so on. So basically, in an ecosystem, people would have self-description of what their input service is, what the hardware requirements are, and so on, and then you have schedulers. This is not totally new. I mean, there's no essentially new concept to this. It's just putting pieces together that already exist, put some glue around it, and of course, there will be a certification instance, at least for the part of Europe, where you can get certified that you meet certain standards, but to actually technically run this, you don't need this. If you don't care about the privacy standards, you just want to do this dynamic contracting, you can just take this toolbox and set it up and run it here. One key idea, and if you're from HPC, this is absolutely not new, is of course we want to have the services, and the services is kind of the algorithm or whatever you want to the actual compute to be executed where the data is. So the key component here is also portability across platforms. So the key idea later on is that someone's hosting their data on AWS, someone's on Google, and you have a service, and if you're compliant with the system, someone could schedule your service to where their data is, and then keep the output there, and the entire system kind of guarantees the access rights and so on. Good. In sake to keep in time, this was a kind of a rough overview. Of course, we could dive deep into the technical details of everything. If you have questions on this, we're around. We have a little booth. You can just stop by and ask us. And I think it's worthwhile to actually have a look at this, even though it's kind of this crazy European thing with this European Union communist-style top-down approach. That at least what it sounds like to the ears of, from a US perspective, oftentimes. But I guess the essence of the problems being addressed there, and you can take the privacy issues that we always have in Europe, you can put them aside because they are only actually a minor part of what this is all about. This is about how to have this digital economy running with many, many partners working on one larger data-driven project. And I think that's what most of you could benefit from.
We have time for questions. I'm surprised that the cloud people are not mauling you at this point now, but...
Well, the cloud people are all in there. If you look at the industry part of the consortium, everybody's in there.
Okay. They're going to take in European level regulations?
It actually doesn't matter. I mean, if you're a hyperscaler, right? You still want to do this business in the end. And I think most of them have realized that it's not only about the privacy thing, but it's about how to organize this. And
yeah, I actually worked for a purpose-built HPC cloud company a while back that got acquired, but the concern, your data sovereignty issues are definitely huge. It got to the point, I can see why some of the big cloud guys would want to do this because they basically end up having to build a data center in every country if they want to do business in that country, right? So by doing this, it might, offload some of that. But the other thing, and I think you got to it, and it probably solves it, another big driver we heard for the cloud was the fact that you had US companies and European countries, the follow the sun model of development, right? You get developers wherever you can get them. And the moving data around all over the place was kind of crazy. So having the cloud enabled a lot more collaboration, if you will. So I guess by putting additional standards and privacy on this, sounds like you're solving a lot of those problems. Is that kind of correct?
Definitely. I mean, if you give this talk in Europe, the privacy and data sovereignty issue will be much higher on the agenda. But I've been around in the city for a while, and especially, I mean, in seismic processing or in the energy sector, you don't process personal data, right? Nobody cares about the privacy issues of, I don't know, subsurface. Yeah. So that's why I kind of put the emphasis on these workflows and how shared workflows between different partners could be organized.
Hi. You mentioned about the data spaces, right?
Yeah.
I wanted to draw some similarities, right, with the OSDU initiative. And OSDU also talks about like standardizing these data sets, right? And essentially wanted to get like a cloud agnostic data model, right? Yeah. And it's interesting, actually. Are you aware of OSDU? And it seems like, Gaia-X is much larger than OSDU, but it looks like a lot of similarities, right? And can you comment on if you come across?
I think the main thing with Gaia-X is that people realize there will be not one big solution that fits everything. So basically, the design is to have this toolbox, right, that is supposed to enable people to build their data spaces on their demand, and then certain types of industries, certain types of applications need to find their own APIs and their own data formats, and it's not possible to find one data format that fits it all and one set of rules that fits them all. And the biggest misunderstanding with the entire project is that people are always talking about the European cloud, and there's no thing. No such thing. You should call it the European Cloud Toolbox or something like this, because there's no actual hardware and there's not one system of standards. It's just a system that allows you to minimize the effort to standardize the workflows for certain applications or industries.
No more questions. Let's thank Janis.